In this video, we're going to look at the basic rules of integration. So we have the integration of k dx, and k is any constant, and that's equal to kx plus c. So we're going to add an x to any constant, and then the plus c is the constant of integration. Remember, when you take the derivative of a constant, it goes to 0. So when we're taking an antiderivative, we need to add a plus c to each indefinite integral. And then the next rule is the power rule of integration. So we have the integral of x to the n dx is equal to x raised to the n plus 1 divided by n plus 1 plus c. So we're going to add 1 to the exponent and divide by the new exponent. The antiderivative, or the integration of e to the x dx, is equal to e to the x plus c. Remember, the derivative of e to the x was e to the x, so the antiderivative of e to the x is e to the x. And then the integral of 1 over x dx is equal to the ln of x plus c. So now let's take a look at some examples. In this first problem, I have the integration of 8 dx. So I'm going to add an x to it. So I have 8x plus c. And if you're having a hard time remembering this rule, remember that x to the 0 is equal to 1. So you could rewrite 8 as 8x to the 0, and then you could use the power rule. So we add 1 to the exponent and divide by the new exponent. And the new exponent would be 1, so that would leave you with 8x if we took the integration of this to the 1 divided by 1, which is also 8x, and then plus c, our constant of integration. In this next problem, we're going to use the power rule. So we have the integration of x cubed dx. So we're going to have x to the n plus 1, so 3 plus 1, divided by 3 plus 1, and then plus our constant of integration. And then we can simplify this to x to the 4th divided by 4 plus c. In this next example, I have the integration of x to the 5/4 minus 1 over x to the 3/2. And just like when we took derivatives, it's good to rewrite these first with all your variables in the numerator so we can use the power rule. So here I'm going to rewrite this as x to the 5/4 minus x to the negative 3/2 dx. And now I'm going to add 1 to each exponent, and I'm going to divide that term by the new exponent. So we have x to the 9/4 divided by 9/4 minus x to the negative 1/2 divided by negative 1/2 plus our constant of integration. And now I want to simplify this. So remember, when you divide by a fraction, you multiply by the reciprocal. So I'm going to flip this fraction and put it in the numerator. So I'm going to have 4/9 x to the 9/4. And then we have negative and a negative, so now we're positive 2. And we have x to the negative 1/2, so I'm going to put it in positive in the denominator, plus our constant of integration. The next example I have is the integral of x to the 6th minus 7x, all divided by x cubed. And I'm going to rewrite this without the fraction. So I'm going to have the integration, and here I have x to the 6th divided by x cubed gives me x cubed, minus I have 7x divided by x cubed, giving me 7x to the negative 2 dx. And now I'll use the power rule. So we add 1 to the exponent, x to the 4th divided by the new exponent, 4, minus 7x to the negative 1 divided by negative 1 plus c. And now let's simplify this. So we have x to the 4th divided by 4 plus 7 over x plus c. This example has an exponential in it, and remember that the integration of e to the x is just e to the x, and then we have a constant. So we're going to have e to the x, and then the antiderivative of 3 is 3x plus our constant of integration. In this last example, I have the integration of x squared minus x to the negative 1. And whether you write this problem in this form or you choose to rewrite it like this, we can rewrite this as 1 over x dx. Remember, the integration of x to the negative 1 or 1 over x, because they're the same thing, is the ln of x. So here we're going to add 1 to the first term's exponent, so we have x cubed divided by the new exponent of 3 minus the ln absolute value of x plus our constant of integration. And that's it for the basic rules of integration.